Hello, dear students. This is your professor, Lázaro Pino, and now I want to explain you some activities that are very important for you in the following weeks. Well, we are going to speak about compounds and chemical reactions. In week number 5, that is the following one, we have the first exam on Monday. So please try to answer all the questions in your homework because the exam is always in Cengage and you can begin the exam on Sunday so that you can have 3 hours long in order to make it. When you begin the exam, you have 3 hours. And there are some questions, so you have to be careful not to lose time in order to complete your exam. Well, the compounds can be classified into covalent and ionic compounds. And the classification depends on the main bonds between the different atoms in the compound. Covalent compounds are usually found when you have two nonmetals bonded. For example, carbon and hydrogen, or carbon and oxygen. Ionic bonds are found when you have the combination of a metal and a non-metal. Examples, sodium and chlorine, and sodium and the anion hydroxide. In this case, the anion is made by two atoms. Also, we can classify the inorganic compounds into acids, bases, and salts. Let's continue. Let's see how to name cations. Well, let's begin by telling you that a cation is an element that have lost electrons and get a positive charge. It happens in the metals. In the case of the cations, they have the same name of the element, but you add the word ion. For example, potassium ion. The anions are atoms that have gained electrons. They have extra electrons, so they have a negative charge. For example, oxygen gains 2 electrons and makes oxide, and you change the ending of oxygen by "ide," and you add the word ion. Here you have how to write formulas from names of compounds. The name here is calcium chloride. Well, you know that you have calcium, then you write Ca. And you have chlorine because chloride comes from chlorine. Then you add Cl here. Always the positive one goes first and the negative one goes after. The cation first, the anion after in this case. As calcium has a charge of 2+, and chlorine has a charge of -1, then you need 2 chlorine to cancel out 2 negative charges with 2 positive charges. So you write here a subscript that indicates that you have 2 chlorine per 1 calcium. And now the compound is correct. And here you have magnesium oxide. Magnesium is in group 2, so the charge is positive 2. And oxygen is in group 6, so the most common charge is negative 2. As they have positive 2 and negative 2, you cancel out both charges and you don't write any subscript. When you don't write a subscript, you think that you have 1 oxygen per 1 magnesium. Here you have barium phosphide. Barium is in group 2, so it's positive 3, 2, while phosphorus is in group uh, 5, so it will be negative 3. What you do in this case, if you interchange, you put B3 as subscript in barium and the 2 of barium as subscript of phosphorus. In the case of sodium sulfide, sodium is +1 because it's in group 1, and sulfide is in group 6, so it's negative 2. Then in this case, you interchange. The negative 2 goes as subscript of sodium, and the positive 1 goes as subscript of sulfur. Well, remember that an ion always changes the ending by "ide," and the cation remains the same name of the atom. Here you have some examples. Strontium and chloride makes SrCl2. In other words, strontium chloride. Calcium sulfide is made by calcium and sulfur. In the case of atoms that have more than one oxidation number, as iron and all the transition metals, or almost all the transition metals, you have to distinguish when you are in front of iron 2 or iron 3. How can you do that? By writing into parentheses the charge, but using Roman numerals. Then you have, for example, copper 2 means copper +2. Tin 4, it means that tin is +4. In an old way to name these compounds, you use the ending O's for the lower charge, for example, ferrous, or ic for the higher charge. Then it would be ferric. But I prefer that you use the numerals. This is the modern way to write the formulas of the compounds and to name them. Here you have that some examples of, for example, lead can be 2 or 4. In this case, it's 2. Then you have to write the charge into parentheses. Iron is 3 in this case. Copper in this case is 2. And titanium in this case is 4. When you have non-ionic bonds, it means that the compound is molecular or covalent. And it happens always when you have two nonmetals bonded, then you have to use prefixes to indicate the number of atoms. The first element is, as always, the name of the element, but the second element change the ending by "ite." Look here, you have the prefixes used according with the number of atoms. In this case, you have two nitrogen, then you say dinitrogen, and you have only one oxygen, then you say monoxide. In this case, you have two sulfur, then you say disulfur. And you have tin fluoride, then you say decafluoride. And here you can see diphosphorus, pentoxide, carbon tetrabromide. In the first element, you don't write mono, never, only in the second one. For example, here, monoxide. Here you have nitrogen trihydride. But in the case of this compound, as in water, you don't name using these rules. You say this is ammonia and water is water. Well, when you have two compounds and one of them, the first one is hydrogen, and they are in the gas state, then you name this as I showed you before. But if it is in aqueous solution, it is an acid. And then you have to use the prefix hydro and the suffix ic for sulfur, that is the element. Then you say hydrosulfuric acid, and you add the word acid because in solution, these gases are acids. Here you have another example, hydrochloric acid. If it is in gas state, then you say hydrogen chloride. But if it is in aqueous solution, it's an acid. Some polyatomic ions contain oxygen, and then they, when you have less oxygen, like in this case, you add the ending "ite." If you have more oxygen, you use the ending "ate." In this case, it's chloro, then it's chloride. In this case, it's chlorate. Sometimes, like in this case, you have more oxygens, then the lower number of oxygen, you put hypochlorite. And when you have the higher number of oxygen, you add hyper to the name chlorate that you had before. All right? This is also known as perchlorate. These are important polyatomic ions. The OH negative is known as hydroxide, and the Cn negative one is the cyanide. Let's see, we have different types of chemical reactions. Synthesis is when two elements or compounds join into one. The opposite is decomposition, when the compound is decomposed into elements or compound or simple compounds. Single replacement is when one single element replaces other in a compound, and then this element that is replaced goes alone. Double replacement is the same thing. This element goes in the place of this, and then this goes in the place that was A before. And then you get two new compounds. The combustion reaction almost always happens in compounds that contains carbon. So the combination of these compounds that contain carbon with oxygen will always produce carbon dioxide and water. In the case of metals, they only form the oxide of the metal. Sorry. So here you have a synthesis reaction or combination reaction. The general formula is A plus B produces AP. For elements, you have carbon combines with oxygen to produce carbon dioxide. But in the case of compounds, you have carbon or calcium oxide reacts with water to form calcium hydroxide. Always, the product is only one compound. The reactants can be or elements or simple compounds. The composition is the opposite. The compound is broken into the elements, like this case, or into two simple compounds, like in this case. Single replacement is with one element replace other in a compound, and this element goes alone. For example, zinc can replace copper, make zinc chloride, and then copper goes alone. In this case, bromine replace iodine from this compound, and then iodine goes alone. It is very important, in order to know when a metal can replace another, to see the activity series. Look, in this case, you have zinc and copper. Can zinc replace copper? Let's go here. Oh, zinc is more active because it's to the right, and copper is to the left. Then it's less reactive. These elements that are after hydrogen are known as double metals because they almost never react. Gold, silver, and copper. In a double replacement, well, the cation takes the place of the other cation, and this cation goes to the place of the first cation. Then you get two new compounds. In order that this reaction happen, it's very important that the one of the compounds that is formed is a solid, a gas, or a weak electrolyte. In this case, barium sulfide is a solid. This reaction is used in order to remove a barium from a compound. Well, it's very important to know the solubility rules in order to know if you make in a reaction a solid or not. For example, compounds that contains nitrate are always soluble. Acetate is always soluble. Chloride is soluble except for silver, this cation of mercury, mercury, and this that is lead 2. When lead 2 is combined with chlorine, they make solids. And here you have the rule, the same rule for bromine and the same rule for iodide. Sulfate is soluble for most of the compounds except when it is in front of strontium, barium, this mercury cation, and lead 2. When you have sulfur -2 sulfide, well, it's soluble for all the compounds like ammonia and the alkali metal. But no, with calcium, strontium, and barium, with these three cations, the sulfide is insoluble. Carbonate is soluble except, well, is only soluble for ammonia and alkali metal with cations like calcium, magnesium, strontium. These carbonates are non-soluble. Phosphate is soluble only for ammonia and alkali cations. And hydroxide are almost always is soluble except for calcium, strontium, and barium. These 3 hydroxides are insoluble. Well, you can have this table at hand in order to do the following reaction. For example, it's very important for you to write the net ionic equation. I will explain it later because first I want you to know how to balance a simple chemical equation. The first step is to write the reactants to the left of the arrow and the products to the right of the arrow. And then you write the elements, iron, oxygen, carbon, in both. And you write the number of iron, in this case, 2, 3 oxygen, and 1 carbon. Here you have 1 iron, 2 oxygen, and 1 carbon. As you can see, iron, oxygen are not balanced. Then you have to balance them. How can you do that? Never adding subscript, only coefficients. You can add here a coefficient. For example, here you have a 1, but you never write the 1. Well, you begin by oxygen. In this case, you have 3 oxygen here and only 2 here. What you do? You put a 3 in front of the 2 and a 2 in front of the 3 in such a way that you have 2 times 3 is 6 oxygen, and here 3 times 2 is 6 oxygen. Now, oxygen is balanced. Let's go to step 2. Well, in this case, you have 1 carbon here and 3 carbon here. So what you have to do? To write a 3 here in front, and now you will have 3 carbon and 3 carbon. In the third step, you can see that iron has a 2 in front, and here you have only 1 iron. What you have to do to multiply by 4? How? by adding a 4 in front of the iron, and now you have 4 iron and 4 iron, and you can say the equation is balanced. In the case of a net ionic equation, you have to find the charge of the ions to determine if the compounds are soluble using the table that I showed you before, and now to balance the net ionic equation. Okay, let's begin. Here you have the rules you have to follow, but I'm going to put here an example. This is the reaction that you have. Oh, since you have a solid here, or a gas, or a weak electrolyte, you can say that there is a net ionic equation. Then first, you balance the equation as I showed you before. When you, in this case, the equation is balanced. One silver, one nitrate, one sodium, one chloride. So what you do, you begin writing in ionic form all the species except for the one that is in the solid or in the gas state. Well, silver plus, and you write aqueous because the solution is in aqueous solution, in water solution. Got it? Well, nitrate is the other anion. Then sodium cation and chloride anion, arrow. The solid remains solid. And then sodium here and nitrate here. In the case of this reaction, you can see that that nitrate is in both sides of the reaction. So you can cancel nitrate and also sodium. These are called spectators since they don't take part in the reaction. They remain in ionic form. But silver combines with chloride to form silver chloride that is a solid. And this is the net ionic equation. Well, I hope that you understood what I explained you. And that's all for today. Thank you very much. See you soon.